test 15A review. Enough, this is for you in case you're going to watch later.
Sushi problem.
Oh, is it blue?
Selecting, which we got?
What's the answer to 13?
13. It has no solution, so it's inconsistent. I really don't.
Can you do 13?
I'm gonna look.
Because 2 can go into 20 and so can
'Cause I got an answer for it too.
Yeah, I got 17.
Here's the gist, ladies and gentlemen. Okay, the only thing you need to do for problem number 13 is solve them both for y and see what their slopes are like. Because if they have different slopes, you know what they say, different slopes for different folks. If they have different slopes, no matter what they are, if the slopes are different, it's one solution. Because eventually they're going to cross somewhere. Okay, so if the slopes you get for these are different, it's going to be one solution. Which, I don't know, we should probably write down what consistent, inconsistent. You know, I don't even care about that. Tomorrow things you just say one solution, no solution, or infinite solutions. Because that's what we are doing. Different slopes means it has just one solution. If they both have the same slope, there's two choices. Okay? If they have the same slope and the same y-intercept, okay, that means it's going to be infinite solutions, because it's the same line. And if they have the same slope, but different y-intercepts, that means there's no solution. Because they never cross, they're just parallel lines. So in order to figure that out, you are going to have to take this equation and solve it for y, just to see what their slopes are like. So if you have, I wish I had a place to do that. I'll do it down here. If you have 2x minus 4y equals 20 and you're solving for y, first thing you do is subtract over the 2x. If you subtract 2x over, you get minus 4y equals negative 2x plus 20. I'll be there if you didn't catch that, just move 2x over. Now to solve for y, I'm just going to divide by a negative 4. And you need to divide both of these by negative 4. And you end up with a positive 1/2 x plus 5. So that is why you compare this equation to this equation. They have the same slope, but different y-intercepts. That's why it is no solution. When you graph those out, they will be parallel lines that will never cross. Had this ended up being a negative 6, then it would have been the other case where there's infinite solutions because they're right on top of each other. Any answer that fits on that line would be they go on forever. I thought that was pretty exciting right there. Lizzie, lead them.
Number 2.
Number 2. And you're wondering why you got a.
Yeah.
Alright, well, let me do as best I can freehand here.
Like I graphed it fine. It was just trying to.
Well, and maybe where you went wrong was the,
equation.
well, not necessarily the equation, but how you graphed it, and what you used for graphs and when you translated that. For example, your x values go by 1, so that's not so bad. You know what? I'm actually gonna undo those lines because I don't need the negative parts of my graph, so I'm just gonna do the positive parts. Okay, and x, the range of x went from 1 to 6, so I'm just gonna do 1, 2, 3, 4, 5, 6. Y, on the other hand, went from 0 to 16. And I don't know if you want to do all those, but maybe I'm going to go by 2's on the y-axis. 2, 4, 6, 8, 10, 12, 14, 16. And then when we do 1, 5, 2, 4 would be about right here. 2, 8, 2, 4, 6, 8, 3, 9, about right there. 4, 10. is about right here. 5, 13, 1, 2, 3, 4, 5, 13, what's that, right about here maybe? And 6, 16 is up here. Here's what I'm talking about. So you drew your straight line. Let me draw a line here. You drew your straight line, and you should try to go through the middle of all that. And then trying to find the equation. First of all, where did it cross the y-axis? And on mine it came close to 3. Like I said, if you have anything from 2 to 4 to whatever, so I get plus 3 for my y-intercept, and the problem we came up with was a slope. And I don't know if you made your, if you changed your y-axis, did you go by 1s on your y-axis, or did you go by 2s, did you go by something else? Because that's where you have to be careful.
I want about 1.
Okay, well then it shouldn't matter. But if you make this your triangle, if I make this my triangle and pretend it crosses right there, okay. My triangle high is going to be 1, 2, 3. It looks like it's 4 high by 1 over or something like that. And again, as long as you're close, I don't know. Did you do the height on top? Did you make that your top number? Because that would, if you had 5/3, it'd be better than 3/5.
Yeah, I think I did that. I put that.
So your triangle is only 3 high and then 5 wide, because if you do that kind of a line, it's going to look a lot flatter than that.
Yeah. See,
mine is probably what, 1, 2, 3, 4. It's probably 5 over 3. I would get 5 over 3, I think. And again, since it's not an exact science, if you have something relatively close, I'm sure I'll give it to you. But 3/5 is a completely different thing. Unless you're like Katie Nolan, who didn't really follow the dots and just kind of made her line go somewhere off in the distance there. You really want to, when you do your trend line, try to split as many of the dots as you can, not be above or below them. Got it, how?
Number 8.
Numero 8.
It's right there.
It is right there. How come I can't get up to it though? Determine whether the lines passing through the following points are perpendicular. So what do you need to know about perpendicular lines? Perpendicular lines have a slope that is negative reciprocal. In other words, you have to find the slope of each one, and if it's the negative opposite slope, then they're perpendicular. Okay, if they have something else, I mean, they're going to be, if they have the same slope, they're never going to, it's not going to be perpendicular. And you need to use that formula where it was y2 minus y1 over x2 minus x1. So if we do that for this one right here, y2 minus y1 over x2 minus x1, the slope that I come up with is 1 over negative 3. So it's a negative 1/3 slope, right? For this one. The slope for the second one is negative 2 minus 4 over 3 minus 5. And when I do that, I get a negative 6 over a negative 2, which ends up being a positive 1/3, because 2 negatives make it positive. So yes, they are perpendicular.
Wouldn't it just be 3?
Oh, I'm sorry, it is 3. Yeah, it's 3 over 1. It is, yes, because it is negative reciprocal. I made this from negative to positive and I flipped the fraction over. Negative reciprocal. My bad. Alexandria Lyric.
Number 1.
Let's start at the beginning with number 1. Casey bought 20 pens, some ballpoint, and some felt tip. Ballpoint pens cost 49 cents each. Felt tip pens cost 95 cents each. If Casey spent 48 on pens, how many felt tip? This one, I'll admit, is a little goofy. Okay, but the way they want you to do this is you're going to write a system of equations. You know you have 20 pens. You might want to off to the side say B stands for the ballpoint pens, and F stands for felt tip. Does anybody still make felt tip pens?
I have some.
I guess they're Sharpies. But what two equations do you get? Well, you know you got 20 total pens, so ballpoint pens plus felt pens equals 20. That's equation number 1. Okay, equation number 2 is this. You pay 49 cents for each ballpoint. Ballpoint costs 49 cents, so I'm going to make these in cents. 49 cents times how many ballpoint pens I have, plus 95 cents for every felt tip pen I have, is going to give me a total of 1,348 cents. I would make them in cents so I don't have to deal with the decimal. And then here is where you have your choice. You can either solve this by substitution or by elimination. Okay, if you do elimination, you're going to have to multiply one of these by the opposite of what's on the bottom there, so either negative 95 or negative 49. I might entertain the notion of doing it by substitution just because I don't have to quite go that crazy with it. Anyways, did anybody do substitution?
It was hard.
It did not work out very
Not
well.
at all. See, elimination worked a lot better. I
I'm
didn't.
looking almost like that as a challenge for me to do it substitution, but I'll do elimination because most of you do elimination all the time. So, your preferences, do I want to multiply by negative 95? And I'm going to say no. Why? Well, because I'm going to get a big negative number up here that I'm going to subtract and get all sorts of goofy things. So I'm going to go by negative 49. Can I do that?
Yeah.
So I'm going to multiply everything by negative 49. Negative 49. Negative 49 and 20 times a negative 49 gives me 0, 18, 1, negative 980. Nobody's agreeing with me, but I'm going to go with it.
Yeah.
Okay, so now when I add these together, gone. 49 from 95 is, I'm guessing, 46.
Yeah.
Help me all that. And then if I take 1348 minus the 980 from the top, I get, 368. Yeah, maybe you're right. Elimination probably would be a little cleaner. Divide by 46, and that's going to tell me how many felt tip pens I have. 368 divided by 46. I'm going to cut them in half just because I can. What's this? 184 over 23. I take 23 into 184. I just reduced this because 20 times a negative 49 is negative 980. And then I'm guessing this is 8. Woo-hoo. So there are 8 felt tip pens, and then 8 plus what number is 20? There would have to be 12 ballpoint pens. What did they ask you? How many felt tip pens? It is a little awkward, mind you, but it still worked out. How many people got it right?
Personally.
Katie.
Number 11.
El Número El 11. Oh. I love the Ortiz family. Anyone else know them? Ortiz. Ortiz family's running a hotel room for 3 days. They can spend at the most $400. As soon as you see that, you should think of the equation. If you can spend at the most $400, that means whatever you spend has to be less than or equal to $400. That's the first thing I would write down before I even read the rest, because the most they can spend is this, so this over here has to be less than or equal to that. Okay? There is a service fee of $25, which means no matter what, you have to pay $25. So that's my plus $25. No matter what, I pay that. And then they want to know they're there for 3 days. 3 times how much money can they spend per day after you add $25 to it will give you less than $400. And then it's just a matter of solving that inequality. They can subtract 25, you get 375. 3x is less than or equal to that. Divide by 3, divide by 3. X would have to be less than or equal to $125. Did they say to graph it? No. What can they spend at the most per day? I guess it would just be $125. Well, some of the, those are pretty complicated. Who?
Number 12.
Number 12. Is that one that I messed up right here? Something else in the middle of it? Number 12. Oh, this one's, don't get all crazy on this. Anytime they ask you for where it's undefined, that just means when will this be 0? Nothing more do you need to do, because things are undefined, you can't divide by 0. It doesn't matter what the top is, top can be 0, bottom can't be 0. And if it's something like that and you can't figure it out, all you have to do is do this. When will 3n minus 6 be equal to 0? That's the answer they're looking for. Add 6, add 6. You get 3n equals 6. N when n is 2. That's when it's undefined, because you're getting 0 on the bottom. Did you way overthink that one?
Yeah.
Just for point of order here again, you know, this has 2 answers. Anytime you have an absolute value equation, you've got the positive answer when x is 5, but you also have the negative answer, because it's either one of them. Absolute value of negative 5 is also positive 5, such that, and hitherto, Alexandria,
Number 14.
number 14. Great. Determine whether the sequence below is an arithmetic sequence. If yes, an arithmetic one, ladies and gentlemen, is one that you can do by adding or subtracting, I believe. In other words, in the common difference just means what are you adding or subtracting each time. And if you look at this, you know, to go from 7 to -1, you add 6. To go from -1 to 5, you add 6. 5 to 11, you add 6. So the common difference is just 6. You add 6 to that thing and you get 17. 6 plus that is 23. I should really look at tomorrow's. Look and see if it gets any more difficult than that. What is this? 15 what? A? It doesn't get any harder than that. If you missed this one, I would be extremely disappointed. Everything's the same, just different numbers. 15, anybody while I'm there smiling? 15? No? Just checking. Nothing else? Less? Nothing? All the rest of you got bango righto? Gwen?
18.
Well, don't ask it like that. Number 18. And again, people get least common multiple and greatest common factors mixed up. Multiples are counting by. And this one you probably could do the old-fashioned way and probably still get the answer, where you just, you know, you write down all the multiples. You know, 10 is, you know, 10, 20, 30, 40, and 8 is 8, 16, 24. But there's probably a quicker way to do it when you've got so many different ones. So remember what we'll do. Step number 1 is prime factorize them. If you prime factorize 6, it's pretty simple. 6 breaks down just to 2 times 3, right? If you prime factorize 8, it breaks down into 2 times 2 times 2. Just kind of skipping a little step there. And if you prime factorize 10, it's 2 times 5. Now what do you do once you prime factorize them? To find your least common multiple, kind of how you,
The most of each number.
right, you take the most of each number that you have in any one particular group. Okay, so I look for the most 2's, that's this one. So I take 3 2's. Which one has the most 3's? Well, this one has 1. which one has the most 5, that one it has 1. And then when you remultiply this, you will get the least common multiple. 8 times 5 is 40, 40 times 3 is 120.
I forget, how do you do grades common factor?
Greatest common factor is you just take what they all have in common. The only thing they have in common is one single 2. You don't have to do it my way, I'm just telling you the best way.
I think it's just to go through.
Wait, so you'd rather write down all the numbers?
No, I didn't.
Oh. I'll enter, if you can.
I just circled this and counted as one, and then I just.
If it works every day, I'm good with that. But what would happen if this had another 5 in it?
Still tiny.
Then you multiply by another 5? Okay.
So we're
Alright.
gonna.
Emma Kate Morkert.
Number 6.
Number 6. 3, 6. Yeah. Number 6, I would say, is best thought of like this. When you have the square root of a fraction, that is the same thing as taking that square root sign and putting it both on top, the square root of 4, over the square root of 121. Same thing. And then simplifying it from there. Does 4 have a square root? What a square root of 4 is 2. And 121, 11. And that's it in a proverbial nutshell. When?
10.
Yeah. When you see a trinomial, the first thing you're supposed to do is see if you can factor something out of all 3. Can you? No, you can take a 3 out of this one and a 3 out of that one, but you can't do it out of that. So there's nothing you can do there. You have to then just think about it as a binomial times a binomial. And that's that whole reverse FOIL thing. FOIL. Fortunately, there's only one way to split up 3x squared. It is to go 3x and x. Okay. Now you have to think about, you jump all the way over here and think what times what gives you 6. Now your choices are 6 and 1 and 2 and 3. So you have to just keep trying all those combinations so that you can get a positive 11 in the middle. And the thing to remember is this, Gwen. Whatever number you put here is going to be multiplied by this 3x. So if I put a 6 here and a 1 there, I have to take 6 times 3, I get 18, and then plus another 1 would be 19. So it can't be probably that one because that's too high. I could put the 1 here and the 6 there, and then it's 3 times 1, which is 3, plus 6, which is 9. That's still not going to give me the right answer. So I'm going to go back to my 3's and my 2's. I could put 2 here and 3 there. 3 times 3 is 6, plus another 3 is 9, still not right. Or I could put a 3 here and a 2 there. 3 times 3 is 9x, plus 2x will give me that 11x. And they both have to be positive. There's only one way to get a positive ending and a positive middle, and that's for both of those to be positive. So that's kind of the breakdown there. Does that help? Vaguely. How about problem number 40? Did anybody miss problem number 40? How about this one? Problem right here that says 40. It should be problem 4. Let me just warn you or tell you what I see a lot of people forgetting to do. Anytime this 2 is outside of a parenthesis, that means it is everything inside the parenthesis gets squared. So you square the 6. 6 times 6 is 36. You square a to the 4th. A to the 4th squared. You multiply exponents together, so you get a to the 8th. B to the 2nd power squared. Again, you multiply. You get b to the 4th, which would have been the same as you added it.
Oh, I have that.
But that is what the answer should be.
Oh, not doing it.
Margaret, 5?
No,
No.
for number 4, can you just like write down 6 a to the 4th b squared and multiply by that?
Oh.
And exponents?
You could just write this down twice, you mean?
Yeah.
A to the 4 b squared, sure, times 6a to the 4th b squared, yes. By all means, if that's what you like to do on that, feel free, easily, yeah, it's probably not a bad idea. Parker, what about you, anything? It's all clear, crystal? Well, who's done with that? So let it be written, so let it be done.
Yes, thank you.
Those of you in TV land, let it be noted that I asked. Nobody else had any other questions on any of these other problems. Wait, Mary Schubert comes through, yes.
13.
Number 19. Oh, yeah, and I was hoping somebody would ask on this because this is where a lot of people go astray. Okay, when you do this, to get the letter A by itself, if you have negative 2A is less than or equal to negative 8, anytime by multiplication or division, you change the sign of the letter, the sign has to change as well. Okay, so maybe it would help to do just forget about the negative right away and just do this where you get a negative 8 is less than or equal to a negative 4. And then say, okay, now I'm just going to change that to its opposite, that to its opposite, and that to its opposite. But either way, you're going to end up with A is greater than or equal to 4. Okay, this one it doesn't change because you're not changing. The x is already positive, so the sign is not going to change. You're just going to subtract 6, and it's going to be a negative 2. The variable changes signs, then so does the. Really, nobody has a problem with this one over here. This is one of my favorite problems.
Sure, 15.
Did you get it right?
Yes. Let's just do it.
Really?
I love money problems.
Well, this is my favorite way to do
really
it.
easy, and I didn't use the box.
Well, I know, but, and I tell you, I've done it so many years without the box that I like the box a lot. First thing, figure out if it's a marks up or marks down problem. If it's marked up, then you have the original number plus how much percent up equals your final price. This is your percentages, this is the actual price. A store marks up the price that they purchased for $25. So originally, well, let's just do this. They mark it up 25%. So the final price you pay is 125%. They purchased it for $25. They want to know both of these, this and this. And you can do it any way that you want to do. I suppose you could even think about it like this. To go from 100 to 25, what do you have to do? Divide by 4. So if you divide 25 by 4, it's not going to work out too nicely, but you do get some dollars and cents here. $6.25. And you don't have to redo all of this again because you can just add. Now you know what the original price is. The markup was $6.25, so that's where the $31.25 comes from.
I just because we put over
Let's see that commercial.
Are you doing this one differently too than me? I'm doing that. How's it work for you? Anybody going home?
My dad had Elvira on this one.
Had what?